Hello, this video will concern the divisions of chemistry. The scope of chemistry, then, is so enormous that my introduction to it and the subject itself would wallow amorphously like a stranded spineless whale, without the imposition of some kind of structure. Chemists have drifted into a structure that helps them to carry out their activities and congregate it like-minded assemblies and develop their procedures, much like individual states develop their policies and economies. Unlike most states, the boundaries are blurred, and often striking advances are made where two cultures overlap. That is essentially the case when the subject is as mature as chemistry currently is, where each domain of activity is thoroughly explored and inspiration might most fruitfully come, just like in art, at fertile overlapping boundaries and at the frontiers where chemistry overlaps other disciplines. For our purposes and to understand the general structure of chemistry for the sake of this introduction, it's helpful to appreciate this division into various branches and to see in broad terms their contents. The divisions of chemistry still pervade university departments, courses, and the journals where discoveries are reported. And so a description of them is still an important component of a visitor's guidebook. But be warned, frontiers, both intellectual and departmental, are melting. The broadest, most important and conventional and still widely observed division of chemistry is into its physical, organic and inorganic branches. Physical chemistry lies at the interface of physics and chemistry, hence its name, and deal with the principles of chemistry which, as we have seen, consist largely of quantum mechanics for explaining the structures of atoms and molecules, and thermodynamics for assessing the role and deployment of energy. It's also concerned with the rates at which reactions take place, both at the macroscopic level and the microscopic. In the latter, it seeks to follow the intimate lives of individual molecules as they are ripped apart and then reconstructed as different substances in reactions. A major activity of physical chemistry is its contribution to the interpretation of investigative techniques, particularly spectroscopy. As we shall see in Chapter 5, spectroscopy uses various kinds of light to bring information from within molecules into the eyes of the observer. Such is the current sophistication of these techniques that physical chemists must bring all their armory, particular quantum mechanics, to bear on the interpretation of the data. Indeed, so blurred are the activities of chemists and physics in this domain that the name of physical chemistry often leads into chemical physics for some who study the behavior of individual molecules with an approach that lies close to a physicist's. Thanks for watching.